Have you ever wondered why the ocean is salty? Indeed, the vast blue expanses of our planet hold many mysteries, and the salinity of the sea is one of its most captivating. Let's set sail on an enlightening journey to understand why our oceans are more like a bowl of saltwater soup than just plain old H2O. The story begins with rain. Yes, rain. As it falls to Earth, rainwater absorbs carbon dioxide from the atmosphere, forming a weak acid. This slightly acidic water weathers rocks on land, a process that releases minerals. Among these minerals is salt, primarily in the form of sodium chloride. Rivers and streams then do the heavy lifting, carrying these dissolved salts from the mountains all the way to the ocean. Over millions of years, the accumulation of these salts has given our oceans their characteristic briny taste. But that's just scratching the surface. There are more intriguing details to this saline saga. Stick around as we dive deeper into the salty secrets of our oceans. Salt doesn't just magically appear in the ocean, it comes from somewhere. But where? Let's embark on a journey, not across seas, but across time and terrain to uncover the origins of ocean salt. Picture vast landscapes and towering mountains. These aren't just spectacular to look at. They are also massive storehouses of minerals, including salts. Over eons, a process called weathering, aided by rain, wind, and chemical reactions, breaks down these rocks, releasing salt and other minerals. Now imagine a raindrop landing on a freshly weathered rock. This raindrop, now infused with microscopic particles of salt, makes its way into a nearby stream, eventually joining a river. It's fascinating to consider that rivers, those ribbons of flowing water that cut through continents, are on a relentless mission, transporting these salts to their final destination, the ocean. According to data gathered by Google, rivers worldwide carry an astonishing 4 billion tons of dissolved salts to the oceans every year. Yes, that's billion with a B. This colossal figure illustrates just how dynamic and continuous this natural process is. But the journey doesn't end at the mouth of the river. Once these salts reach the oceans, they contribute to the salinity that characterizes our great seas. This salinity is not just a trivial fact, it is crucial for the ocean's complex ecosystem, affecting everything from the density of the water to the types of organisms that can thrive in these environments. Moreover, the composition of these salts can tell us a lot about the geological and climatic history of the Earth. Each particle carries a tale, a whisper of the planet's past activities, from volcanic eruptions to shifts in ancient climate patterns. So rivers are like nature's conveyor belts, transporting salt right into the ocean. What exactly is this salt made up of? When we sprinkle salt on our food, we're mostly using sodium chloride, but the story doesn't end there, especially not for ocean salt. Sodium chloride actually comprises about 85% of the salt in seawater. It's a compound that results from the bonding of sodium and chloride ions, crucial elements that play significant roles in biological processes and the Earth's climate. Now, let's break it down a bit further. Sodium, represented as Na on the periodic table, is a highly reactive metal. Alone, it's quite volatile, but when it meets chloride, a halogen element, they form a stable compound, sodium chloride, or as we commonly know it, table salt. This interaction is fundamental to understanding not just table salt, but the vast salinity of our oceans. But seawater isn't just a soup of sodium chloride, it contains a cocktail of other minerals and salts such as magnesium chloride, magnesium sulfate, and calcium sulfate. These are derived from the Earth's crust or carried into the oceans via rivers and streams. Each of these elements contributes not only to the ocean's salinity, but also to its capacity to support diverse marine life. The complexity of salt composition in the ocean is a testament to the intricate processes our planet has undergone. From the erosion of ancient rocks to the subtle leaching of minerals, every grain of salt tells a story of Earth's dynamic history. It turns out ocean salt is more than just your typical table salt. Now let's heat things up a bit with hydrothermal vents. Deep beneath the ocean's surface, where sunlight dares not venture, lie some of the most fascinating and fiery features of our planet's underwater landscape, the hydrothermal vents. These are not just spectacular natural wonders, they play a pivotal role in the salinity of our oceans. Hydrothermal vents are essentially underwater geysers that are formed along the Earth's tectonic plates. As seawater seeps down through cracks in the ocean floor, it is heated by the magma lurking below the crust. This superheated water then dissolves minerals from the surrounding rocks and re-emerges through the vents at temperatures that can exceed 700 degrees Fahrenheit. The water is not just scalding, It's loaded with a cocktail of minerals, including vast amounts of salt. According to research published in the American Journal of Science, these vents are significant contributors to the ocean's mineral content, particularly salt. The dissolved minerals, which include sodium chloride, common table salt, as well as other compounds, are then dispersed by ocean currents, mingling with seawater and increasing its salinity. This process is cyclical and continuous, contributing not just to the salinity, but also to the complex chemical environment of our oceans, which supports diverse ecosystems. From tiny microorganisms to large aquatic creatures, life thrives around these vents, drawn by the minerals and the warmth they provide. These underwater geysers are crucial in seasoning our seas. With all this salt pouring in, why don't the oceans just keep getting saltier? A curious question indeed. It appears that the oceans have their own, rather ingenious ways of managing salt levels. Let's dive into how nature pulls off this balancing act. Firstly, one of the primary methods through which oceans regulate salinity is through the formation of salt deposits. These occur when saline water evaporates, leaving behind minerals that form layers of salt. Over eons, these layers can become vast salt deposits, effectively removing large quantities of salt from the oceanic system. Studies such as those found in the American Journal of Science illustrate how these geological formations have played a critical role in stabilizing ocean salinity over millions of years. Moreover, marine organisms also play a significant part in this salinity saga. Many sea creatures, from the tiniest plankton to the largest whales, use salt and other minerals found in seawater to build their bodies. For instance, PubMed research highlights how coral reefs, through a process called biomineralization, convert dissolved minerals into hard skeletal structures, thereby locking away salt. This biological filtration is a subtle yet powerful force in controlling the ocean's salinity. Furthermore, certain plants in mangrove forests and seagrass beds help remove salts from the ocean. They absorb salt and other minerals from seawater, which they use to support various physiological processes. This not only aids in their survival in saline environments, but also contributes to the overall salinity balance of the oceans. It's fascinating to note that despite the continuous influx of salts through rivers and hydrothermal vents, these natural processes synergistically work to prevent the oceans from becoming excessively salty. This delicate equilibrium ensures that marine ecosystems thrive, supporting a biodiverse environment. Thus, while the oceans continue to receive vast amounts of salt daily, these natural mechanisms, geological, biological, and ecological, collaboratively ensure that the salinity remains relatively stable. Nature has its ways of keeping things in perfect balance. So why should we even care about how salty the ocean is? Well, the salinity of the oceans isn't just a curious detail, it's a vital part of the planetary system. Salinity influences ocean circulation patterns, which in turn affect climate regulation. These patterns are crucial because they help distribute heat around the globe. Without this natural heat distribution system, some regions would be unbearably hot, while others would be frigid. Moreover, salinity is a key player in supporting marine biodiversity. The concentration of salts can determine which organisms thrive in different parts of the ocean. From tiny plankton to massive whales, every marine life form depends on the delicate balance of salty waters. So when we talk about changes in the ocean's salinity, we're discussing potential shifts in climate and disruptions to the ecosystems that billions of species, including humans, rely on. This is why monitoring and understanding ocean salinity is not just about science, it's about survival. The salinity of our oceans affects more than just the taste of the water. Now that you know the secrets behind the saltiness of our oceans, what are your thoughts? Dive into the comment section below and let us know. Perhaps you have a question about hydrothermal vents or the intriguing balance of salinity? We're here to keep the conversation going and deepen our understanding together. If you found this journey through the salty seas enlightening, why not share this knowledge with others? Give this video a thumbs up, share it with friends, and spread the wonder of our blue planet. Each share helps us bring more exciting educational content your way, and if you're as passionate about uncovering the mysteries of the natural world as we are, consider subscribing to Facts Academy 0122. Here, curiosity never ends and every video is a new adventure. Thank you for watching, and remember, every drop in the ocean counts.